Hello everyone, I am Seema, working as Assistant Professor in Department of Mathematics, Maharaja Institute of Technology, Mysore. Today, in this session, we are going to discuss first semester engineering mathematics, calculus and linear algebra. In that third module, integral calculus. We should know what is a calculus. Calculus is a branch of mathematics which helps us to understand changes between the values that are related by a function. The calculus is divided into two parts. One is differential calculus, another one integral calculus. Then what is differential calculus and integral calculus? Differential calculus that determines the rate of change of quantity, whereas the integral calculus finds the quantity where the rate of change is known. Okay. So, in this module integral calculus, we are going to learn the theory and application of integral calculus. So, if we come to the application part, we are using integral calculus in finding the area and volume bounded by the curve, which is in our prescribed syllabus, and also in all engineering fields, in economics, in medicine, we are using the concept of integral calculus. Now, if we come to the theory part, in our PU classes, we learn how to integrate a function in a definite and indefinite interval. Now, in this module, we are going to learn how to integrate a multiple integral. Then what are multiple integral? A definite integral of functions of more than one variable. In our PU classes, we learnt with only one variable. Now here we learn with a multiple integral, that is a definite integral of functions of more than one variable. That may be two variable or that may be three variable. Okay. So for our syllabus, we have two variable and three variable. That is a double and triple integral. Then what are double and triple integral? The integrals of functions of two variable over a region or square are known as a double integral, and also integrals of a functions of three variable over a region or cube are known as a triple integral. Or in a simple words, we can define a double and triple integral as a repeated process of integration of two or a three variable over a given region are referred as double and triple integral, denoted by double integral of f of x comma y dx dy and triple integral of f of x y z with respect to x, y and z. So, in the double integral, we have two variable x and y variable, both x and y are variable now. In triple integral, we have x, y, z as a variable. Okay. Now, in this module, now we are going to learn how to integrate a double and triple integral. Okay. Now, before going to solve the problems on double and triple integral, let me explain how to consider a limit in double and triple integral. So, working rule, we know that in a line integral, in a definite integral, integral of f of x dx, which is between the limit a to b, a constant limit. If I have a limit integral, line integral f of x dx between the limit a to b, the integral of that function, if I have f of x, that will be between a to b, that means x varies from a to b. So here we have only one variable, that is x variable. So x varies from a to b, where a and b are constant limit. So we know that b is the upper limit and a is the lower limit. So we should apply the limit, first upper limit minus lower limit, that is f of b minus f of a, and that will be a finite result. Okay. Similarly, consider a double integral of f of xy dx dy. Okay. Now, in this we have two integrals, right? So the first integral we call as a outer integral and the second integral we call as a inner integral. Okay, first integral is a outer integral and the second one is a inner integral. And if I have a dx here, then inner integral limit stands for x variable and then dy, therefore outer integral limit stands for y variable. And the next thing is the limit may be constant. That means the limits may be a1 to a2 and b1 to b2. That means double integral, the outer integral varies from a1 to a2 and inner integral varies from b1 to b2. That both the limit may be constant limit. The other option is that means double of f of x comma y dy and then dx I consider. Then one may be constant limit. Out of the two limits, one of the limit may be constant limit and our inner limit may be variable limit. That means we can have a function of x. Okay. So, and one more thing, the outer limit is always a constant limit and the inner limit is always a variable limit. Okay. So, how to integrate this or how to consider this? If I have dx, as I told you, if I have dx here, then the inner integral limit stands for x variable and then we have dy, therefore the outer integral limit stands for y. Therefore, I can read like this, double integral of f of x comma y dx dy, where y varies from a1 to a2 and x varies from b1 to b2. And also in this case, in the second type, that means one may be constant limit, another may be variable limit, right. So, if I have dy here, then we know that the inner integral limit stands for y varies from g of x1 or a function of x1 to x2 and then we have dx, therefore outer integral stands for x variable, that is x varies from a1 to a2. Okay. So, whenever I have x variable, suppose if they can interchange the dx and dy here, instead of giving dy dx, we may expect in a question that dx and then dy. Then you are not supposed to consider x limit as x varies from x1 to x2. Even if they interchange here, depending on this limit, that means if I have x variable in a limit place, then that should be a y limit. Okay. If I have a constant, then that should be a x limit, right. Another option is, one more case is, instead of x I can have a y, that means f of xy dx and dy, or I will consider dy dx, then we can rewrite that. Okay. So, this may be a limit a1 to a2 and this will be a function of y1 to y2. So, the maximum option will be this, that means I can have a constant limit, one constant another variable and one constant another variable. Now, in this limit I have dy here, then and in a limit place I have a y variable, then no, we are not supposed to consider this as a y limit, because whenever I have y in a limit place, that should be a x limit or x variable limit. So, I can rewrite this as double integral of f of xy dy dx and then dy. So, that first inner integral, outer integral varies from a1 to a2 and inner integral is a function of y1 to y2. Okay. Now, here dx, therefore x varies from a function of variable y1 to y2 and the outer integral stands for y. So, depending on this variable, you should consider whether it is x variable or a y variable limit. If I have y in place of limit, then definitely that will be the limit of x. If I have x in the limit place, then that will be the limit of y. Okay. Now, we are clear with considering the limit for x and y if we have a constant or a variable limit. Now, how to integrate the function? So, in this case, if I have a function of x and y as a product of x and y, then I can split the double integral as a multiple of line integral and I can separate them and I can integrate separately. But whenever I have a sum of the function or difference of the function of x and y, then I can't split the double integral as a line integral. We should integrate one by one. If I have dx first, then keeping y as a constant, we should consider y as a constant and we should integrate with respect to x. Keeping y constant, integrate first with respect to x and apply the limit, then you remains only with the y variable. Okay, then integrate with respect to y. So in this case, I have one as a constant limit, another one as a variable limit. Since I have dy first, I should integrate with respect to y keeping x constant. So first integrate with respect to y keeping x constant and apply the limit, upper and lower limit, simplify that, then you will remains with only some constant and a x variable. So once you remains with x variable, integrate with respect to x, right. Similarly in this case also, since I have dx first, so first integrate with respect to x keeping y as a constant and apply the limit, then you will remains with only y variable, then integrate with respect to y and apply the limit, that gives you the required result. If we consider a triple integral, we should know how to consider the limit for a triple integral. Since we have three variables x, y, z, that is, consider the integral will be like this: triple integral of f of x, y, z, dx, dy, dz. Okay. Now, we have three integrals, right. First one is as usually outer integral, second one middle integral, and the last one or the third will be the inner integral. Okay. So again, if I have dx here, depending on the limit value, we should consider first as a dx or dy and then dz. So again here also we have different options. The options are, I can have all the limits as a constant limit, all the three as a constant. Option is, if I have a triple integral of f of x, y, z, dx, dy, dz, and in a limit place I can have first as a constant limit, second one also as a constant, and third one as a variable limit, right. And other option is, I can have triple integral of f of x, y, z, dy, dx, I can write dz, first as a constant limit and other two may be variable limit. And also in variable place, I can have x variable or y variable or a z variable. And also here also we can have here, if I have x, y as a variable, then that will be the limit of z, and I can have here y as a variable, then that will be the limit of x. So let me explain with the example. Okay. So if I consider the constant limit, it may be a1 to a2, b1 to b2 and c1 to c2, right. Integral a1 to a2, b1 to b2, c1 to c2 as a constant limit, right. So if I have dx here, then definitely the inner limit stands for x. X varies from c1 to c2. Then dy, therefore y varies from b1 to b2. And then we have z, therefore z varies from a1 to a2. So as I explained in the double integral, if I have a product of three variable x, y, z, then I can split the triple integral as a multiple of a three line integral. Whenever I have product of f of x, y, z will be the product of x, y, z, then I can separate the integral. If I have a sum or the difference, then I cannot split the triple integral as a product of three line integrals. Okay. So first integrate with respect to x. If I have a sum of the three integrals or a difference of a variables x, y, z, then depending on this dx if I have, then keeping your y and z as a constant, integrate first with respect to x, then your x will eliminate, we left with the y and z, then integrate with respect to y because I have dy then, so integrate with respect to y keeping z as a constant, then your y will eliminate, you left with the z variable only, then integrate with respect to z and apply upper and lower limit. Now, if I have two constant limit and one variable limit, for example, if I consider a triple integral of some function f of x, y, z dx, then dy and then dz, right? So here I have a constant limit a1 to a2, b1 to b2, and the variable limit may be y minus z to y plus z. For example, since I have y and z in a limit place, whenever I have y and z in a limit place, definitely that should be the limit of x, and also we have dx here, therefore x varies from y minus z to y plus z. Then dy I have, therefore y varies from b1 to b2, which is a constant limit. Then z, therefore z varies from a1 to a2. So first integrate with respect to x, keeping y and z as a constant, okay, and apply the limit, simplify, then integrate with respect to y, keeping z constant, and similarly integrate with respect to z. And the next option is, I can have one as a constant limit and other two as a variable limit. Now next one is, I have one with a constant limit and other two has a variable limit, okay, that is the constant limit varies from a1 to a2 and the variable limit is 0 to z square and 0 to x square plus 1, and of course the lower limit may be 0 or any constant number and upper limit may be variable, or I can have a lower limit variable, upper limit constant, okay. Now here I have a limit 0 to x square and we have dy here, therefore this inner integral limit stands for y, where y varies from 0 to x square, and then we have a dx, therefore the second integral is x varies from 0 to z square, and then we have a z, therefore outer integral stands for z limit, that is z varies from a1 to a2. Now to integrate this, first we should integrate with respect to y, right, keeping x and z constant, we remains with x and z variable if I apply and simplify the limits, and then keeping z constant, integrate with respect to x because we have dx then, therefore integrating and simplifying the integral, we left with a z variable. Finally integrate with respect to z and apply the upper and lower limit. In all the cases we will get a finite result or a definite value. Now let us solve the problems on double integral, that is evaluate double integral of x y dy dx between the limit 0 to 1 and x to root x. Now I consider the given double integral as I. So consider I equal to double integral xy dy dx between the limit 0 to 1 and x to root x. Now before going to integrate, of course we should consider the limit of x and y, right. Since I have dy and x in a limit place, this should be the limit of y variable. So y varies from x to root x, and then we have dx, therefore x is a constant limit and it is an outer integral, x varies from 0 to 1. Now keeping x constant, integrate with respect to y, that is integral 0 to 1, x is considered as constant, integral of y with respect to y is nothing but y square by 2 between the limit x to root x. So this stands for y. So y varies from x to root x. Now apply the limit 1 by 2 common, integral 0 to 1 x into, we know how to apply the limit. So upper limit, that is root x whole square, minus lower limit, that is x square dx. Or if I simplify, we have 1 by 2 times of integral 0 to 1 x into x minus x square dx. Now before going to integrate, in the next step I can simplify one more step, that is I equal to 1 by 2 times of integral 0 to 1 x into x will be x square minus x into x square is x cube dx. So we left with only x variable, right? Now I can integrate with respect to x, that is 1 by 2 times of integral of x square is x cube by 3 minus x to the power of 3 integration is x power 4 by 4 between the limit 0 to 1. That is our x limit. X varies from 0 to 1, or we have 1 by 2 times of, we know how to apply the limit, right? Upper limit is 1. In place of x I should replace by 1. 1 by 3 minus 1 by 4. Of course 1 cube is nothing but 1. 1 power 4 is nothing but 1. Upper limit minus lower limit, 0 minus 0, we remains with 0. So if I simplify, we have 1 by 2 times of 1 by 12, or the double integral, the given double integral result or evaluated value is 1 by 2 into 1 by 12, nothing but 1 by 24. Evaluate integral, double integral x cube y dx dy between the limit 0 to 1 and 0 to 1 minus y square. So with as usual method, I consider the given integral as I name it as I equal to double integral of x cube y dx dy, where outer limit with 0 to 1 and inner limit with 0 to root of 1 minus y square. Now the outer limit is constant limit and inner limit is a variable limit. So we have dx here, right, and the inner limit variable with a y variable. Therefore what should be our limit? The x variable varies from 0 to root of 1 minus y square, whereas the outer limit stands for y variable, y varies from 0 to 1. Now integrate with respect to x, keeping your y constant as we done in the first problem, right? There we keep our x constant and we integrate with respect to y, right? Here in this problem, keep your y constant because we are integrating with respect to x first. So keeping y constant, integrate with respect to x, that is x cube integration x power 4 by 4 between the limit 0 to root of 1 minus y square dy. Now apply the limit. We can take out 1 by 4 common. 1 by 4 into integral 0 to 1 y into root of 1 minus y square whole to the power of 4 minus 0 dy, or I equal to 1 by 4 into integral 0 to 1 y into root of 1 minus y whole square whole to the power of 4 become 1 minus y square whole square dy, or 1 by 4 into integral 0 to 1 y into, expand using your a minus b whole square, 1 minus 2y square, that means a square minus 2ab plus b square, that means y square whole square become y to the power of 4 into dy, or 1 by 4 times of integral 0 to 1 multiply by y and then integrate with respect to y. 1 into y minus 2y cube plus y to the power of 5 dy. Now integrate with respect to y, right? We left with all the functions or all variables as a y variable, right? So 1 by 4 into constant y integration y square by 2 minus 2 times of y cube integration y power 4 by 4 plus y power 5 integration y to the power of 6 by 6 between the limit 0 to 1. Now apply the limit. 1 by 4 is a common multiple. 1 by 2 into 1 minus 0, of course 1 square minus 0 square nothing but 1 minus 0. 1 by 2 by 4 is nothing but 1 by 2 into 1 power 0 minus 1 power 4 minus 0 plus 1 by 6 into 1 to the power of 6 minus 0. So, we are left with 1 by 4 into 1 by 2 minus 1 by 2 plus 1 by 6. So, plus 1 by 2 minus 1 by 2 get cancelled. We remains with 1 by 4 into 1 by 6 is nothing but 1 by 24. Problem. Evaluate double integral x y square dx dy. The outer limit is 1 to 2, inner limit is 1 to 3. Consider the given integral as I. I is equal to double integral of x y square dx dy, which varies from 1 to 2 and 1 to 3. Now, in this problem, both the limits are constant limit. We do not have any variable limit here as we solved in the last two problems. Here we do not have variable limit. Both are constant limit. That is varies from 1 to 2 limit and 1 to 3 we have. Now, how to consider the limits? Inner limit stands for x or y and the outer limit is for which variable? That depends on this. So, if I have dx here, then I should consider the inner limit as x limit and the outer limit as y limit, or you can interchange x and y. If you interchange dx and dy, you can interchange the limits of x and y and integrate, you will get the same result. That is nothing but integral. Now, integrate with as usual method, keeping y constant, integrate with respect to x, that is y square constant. Integral of x is x square by 2 between the limit 1 to 3 and to dy. So, 1 by 2 common, integral of y square, integral varies from 1 to 2 y square, apply the limit 3 square minus 1 square dy, or 1 by 2 into integral of y square into 3 square nothing but 9 minus 1 square is nothing but 9 minus 1 8 into dy. Now, take out 8 common, I equal to 8 by 2 nothing but 4 integral of y square y cube by 3 between the limit 1 to 2. I take out 8 common, then 8 by 2 is nothing but 4 and I integrate the function y square. Integral of y square is y cube by 3 between the limit 1 to 2. Now, 4 by 3 constant and we left with 2 cube minus 1 cube. It is nothing but 4 by 3 into 2 cube is 8. 8 minus 1 is nothing but 7. So, 4 by 3 into 2 cube upper limit minus lower limit 1 cube. So, 2 cube minus 1 cube is nothing but 7. So, our final answer is 28 by 3. Now, next problem, evaluate integral, double integral of sine of x plus y dx dy between the limit 0 to pi by 2 and 0 to pi. So, consider the given integral as I. I is double integral of sine of x plus y dx dy between the limit 0 to pi by 2 and 0 to pi. Now, again we have a constant limit as we solved in the previous problem. Both the limits are constant. So, how to consider this is as x limit or y limit. So, as I told you in the previous problem, if I have dx here, then this will be our x limit, then dy. So, outer limit will be y limit. Okay. Now, keep integrate with respect to x 0 to pi by 2. First integral. Integral of sine is minus cos of x plus y between the limit 0 to pi dy. Y is constant, we consider y as constant, right. So, integral 0 to pi by 2, apply the limit minus common cos of, you should replace for x, right, pi plus y and lower limit cos of 0 plus y dy. So we know the standard allied angle formulas, that is cos of 180 minus theta or 180 plus theta. 180 is nothing but pi. Pi plus y, cos of pi plus y, it comes in a third quadrant, right. So that is minus cos y minus cos of 0 plus y is nothing but cos y dy. So minus cos y minus 2 times of cos y, and minus into minus become plus. So the given integral I reduces to integral 0 to pi by 2 times of cos y dy, or if I take out 2 common and integrate the cos function, integral of cos y is nothing but sin y between the limit 0 to pi by 2, or apply the limit for sin, that is sin y is equal to pi by 2 and sin of 0. We know that sin pi by 2 is 1 and sin 0 is 0. So the given double integral value is 2. With the next one. Next problem, double integral of r into sin theta dr d theta between the limit 0 to pi and 0 to cos theta. So consider or name the given integral as I equal to double integral r sin theta dr d theta between the limit 0 to pi and 0 to cos theta. So in the last problems we have x and y variables, right. Now here we have r and theta. Instead of x and y, we have in a polar form r and theta functions, right, theta variables. So how to name? In the same way, if we have dr here and if it is a theta variable, then this should be r limit. R varies from 0 to cos theta and the outer limit will be with a theta. Theta varies from 0 to pi. Now keeping your sin theta constant, integrate with respect to r. So 0 to pi, sin theta is considered as a constant. Integral of r is r square by 2 between the limit 0 to cos theta d theta, or it is nothing but 1 by 2 into integral 0 to pi sin theta into cos, apply the limit, replace the upper limit cos square theta minus lower limit 0 d theta. So we left with 1 by 2 into integral of sin theta into cos square theta d theta, where limit of the integral is 0 to pi. Now how to integrate our sin into cos square? Yes, of course, by the substitution method. So if I substitute for cos, we can't use the integration by parts, we know that. We have to solve using the substitution method. Substitute for either sin or a cos function. Of course, in this case, we have to substitute for the cos function. Substitute or put cos theta is equal to t. Another variable, we replace it by t. Then, if I differentiate with respect to t, then we have minus, in derivative of cos theta is minus sin theta into d theta is equal to dt, or I can replace sin theta d theta by minus dt. Once I replace the theta variable by another variable t, of course we have to change the limit of the function also. If theta is equal to 0, the given limit is theta is 0, theta varies from 0 to pi, right. So if theta is 0, then what is our t? T equal to cos theta or t equal to cos 0, that is t equal to 1. And if theta is equal to pi, then t equal to cos pi. We know that cos pi is minus 1. So we have to change all the theta variable including the limit of the function or a limit of a theta variable in terms of t. So the given integral I reduces to 1 by 2 remains as it is. Integral of sin theta d theta can be replaced by minus dt, whereas cos theta is replaced by t. We have a square t square into minus dt between the limit where t varies from 0 to 1. Instead of 0 to 1 we have 1 to minus 1. So 1 by 2 minus 1 by 2 into, we have minus here, I taken minus common, integral of t square is t cube by 3 between the limit 1 to minus 1, or it is minus 1 by 6 into, I have taken 3 common, so that minus 1 whole cube minus 1 cube, or minus 1 by 6 into minus 1 cube is nothing but minus 1, minus 1 minus 1 will be minus 2. So your answer is 1 by 3. So the given double integral reduced with the result 1 by 3. Problem: evaluate double integral of e power y by x dy dx between the limit 0 to y 4 and 0 to x square. So consider the given integral as I. I is double integral of e power y by x dy dx between the limit 0 to 4 and 0 to x square. So first mark the limit of the variables. We have y here and x variable, therefore this is the limit of y variable, and then the outer limit will be x limit. Now integrate with respect to y keeping x constant. So integral 0 to 4 integral of e power ax, e power ax integration e power ax by a. So in the same way, keeping x constant, integrate e power y by x as e power y by x by, since x is constant, have to divide by 1 by x between the limit 0 to x square dx. Now integral 0 to 4 x into e to the power of y by x. If I consider 1 by x to numerator, it become x between the limit 0 to x square dx. Now apply the limit. I is integral 0 to 4 x into e to the power of x square by x minus lower limit e to the power of 0 dx, or it is nothing but integral 0 to 4 x into e to the power of x, x square by x is reduced with x minus e power 0, we know 1 dx. Now it reduces to integral 0 to 4 x into e to the power of x minus x dx. Now I can split the difference of the two functions as a two integral, that is integral 0 to 4 x into e power x into dx minus integral of x dx between the limit 0 to 4, or we can integrate keeping as it is, or we can split the integral. Now to integrate the first one, we should apply the integration by part, or we know the standard formula, that is a Bernoullis rule, that is integral of product of two function can be obtained by using either integration by part or Bernoullis rule. I consider the x as a first function and e power x as a second function. So we know that first function is a function that is going to differentiate successively in a Bernoullis rule, whereas the second function, that is e power x, is going to integrate successively, right. So we consider the first function in a way that should reduce to a constant by successive differentiation. So apply the Bernoullis rule. First function into integral of e power x is e power x minus derivative of x is 1. We know the differentiation of x. We have not gone to the given problem or given the above step. We obtain the differentiation from this step. Derivative of x will be 1 and integral of x e power x again. Integral of e power x is e power x, right. I can stop Bernoullis rule because I have 1 here. The next step will be derivative of 1 will be 0. So no need to do that step. So your integration by part, or we call it as a Bernoullis rule, we can stop here. Once you have a derivative of the first function as a constant, we can stop our Bernoullis rule. Minus integral of x is x square by 2 between the limit 0 to 4. Okay, now apply the limit. I equal to upper limit 4 into e to the power of 4 minus e to the power of 4, that is upper limit, minus lower limit 0 into e to the power of 0 minus e power 0 is the lower limit, minus 1 by 2 into 4 to the power of 2 minus 0 to the power of 2, or so I reduced with 4 times of e power 4 minus e power 4 is 3 times of e power 4, 0 minus of minus plus e power 0 is 1, so plus 1 minus 4 square is 16, 16 by 2 is 8. So the evaluated result of the given problem is e to the power 3 times of e power 4 minus 7 is our answer.